Hello. Come right on into another moment of accelerated instruction. I am your response to interventionist specialist, Miss Tessie Sanders Madlock, and your online teaching consultant for adult education literacy. Today, in this session, we will start with multiplication. We're going to be regrouping with multiplication. And I want you to be very prepared. Let me get my header up. Go ahead and get your readers, get your 2 or 3 sharpened pencils, and get your colored pens and or overlays for those that may have learning challenges or learning differences so that you can be very successful throughout this lesson. This is my contact slide. Should you need to reach out to me after viewing this presentation, and if you are an administrator and you would like for me to come in to your building and do a professional development or a response to intervention or what accelerated instruction looks like, or mentor your teachers, I would be happy to do such. Now, I'm excited. Let's go ahead and get started. Math has always been one of my challenges. This is my resource. Professors, I want you to see my resource. I got it at half price books for this much. I don't know if you're going to get it for that much now, but for those that are familiar with skill builders, math, and I do believe this was at the 6th grade level, but for response to intervention or accelerated instruction or developmental math, math starts at the 5th, 6th grade level when we talk about pre-algebra or algebra 1. And on the back, see, you can get it at Teacher's Aid for $4.99 if Teacher's Aid is still around. Just letting you know. Here is the ISBN number and the barcode just to give credit to the source. I'm excited. Let's go ahead and get started. As I said, math has always been one of my challenges. You wouldn't know it now. I'm living proof that you actually really have to study. You really have to study those multiplication tables. That's what I mean when you really have to study, because it's going to help you with PEMDAS, which is order of operation. It's studying your multiplication tables will help you with slope intercept, the distributive property, those upper levels of math. All right, let's take a look. Get your scratch paper ready. Okay, if you need scratch paper, I have my calculator ready. Okay, so here we have 87 times 5. Now, let me go ahead and do it in my calculator. 87, 87 times 5. And you can see that it equals 435. Now, how? How do we understand and know that it equals 435? Let's rewrite the problem. 87 times 5. And we are regrouping with multiplication. So you don't have to draw your place value categories. I do because, again, this is response to intervention, developmental math. And some learner may need to see visually, especially my adult ESL learners or my middle school and high school learners that are just struggling with math. Ones, tens, hundreds, thousands. Hopefully my colored pens work. 5 times 7. So we're here. We're going up. Start problem solving. Visualize it. They gave you 5, right? You started at 5. Get up 7 fingers. Count by 5s. Yes, if you need to. Or sometimes you have to have those human manipulatives for those of us that are hands-on learners. And I don't want you to feel shame. You need to use it, hands-on. Count 5, 10, 15, 20, 25, 30, 35. So 7 times 5 or 5 times 7 is what? 35. And I'll switch it around because we are working with our 5 times tables. I'll come down here. 5 times 7 equals 35. And then we will write our 5 here and carry our 3. See? Regrouping. Write your 5 in the ones place. Carry your 3 to the tens place. 5 times 8. 5 times 8. You will add 5 to 35. See, I do this for my beginning language learners, at the level 1 or level 2 stage of understanding the English language. 5 times 8, add 5 onto 35. What comes after 35? 36, 37, 38, 39, 40. So you will write the 4 in the hundreds place and the 0 in the tens place. Go ahead and put an X or a 0 here and move to the tens place. You don't have to because we do not have another number here. So did we get the right answer? I'm going somewhere with this. Did we get the right answer? No. What happened? I didn't add the 3. You didn't add the 3. So I want you to catch simple mistakes like that. I did it on purpose because at some point you should have, I need to add the 3. So take a look. 5 times 8 is 40, but 40 plus 3 is 43. So we will change that 0 to a 3, or I can just write it over. No big deal. 435. No big deal. 435. That is why 87 times 5 is 435. My screen is cracked. Don't talk about my screen. Now let's move to the next problem. So here we will write 435. Now let's tackle 72 times 18. Rewrite your problem. Rewrite your problem. 72 times, and write those numbers neatly. Write the numbers neatly. A lot of your mistakes in math come from poor handwriting of letters and numbers. So that's a skill that you, the learner, the individual, will need to sharpen. Let's go ahead, if you need to, set up your regrouping bars. Ones, tens, hundreds, thousands. We are going to multiply with this set of numbers. Now, let's see what it is. Let me clear my screen. We have 72 times 18, which will equal, let me get it in there, which will equal 1,000. Messages are coming in unexpectedly. 1,296. That is what it's going to equal. So 8 times 2. Well, I need you to visualize it. I need you to make the 8 times tables. Yes, this is how you study. This is how you commit it to memory, is by physically doing it repetitively. Get up 8 fingers. Let each one represent 2. 2, 4, 6, 8, 10, 12, 14, 16. So 8 times 2 we know is 16. We write our 6 in the ones place. We carry the 1 to the tens place. 8 times 7. So we will fall through with this table. We'll fall through with it. 8 times 3 equals, add 8 to 16. This is where the numbers come from. Doing this gives you an understanding of, oh, okay, now I get it. Now my think meter is going from here to here, and then we can get that think meter here. Now hold on. Those that are a little faster and you've got it, great. But slow down a bit. Let everyone else get there. 8 plus 16. Get up 8 fingers. What comes after 16? Okay. 17, 18, 19, 20, 21, 22, 23, 24. We know that 8 plus 16 is 24. But we need 8 times 7. 8 times 4. Add 8 to 24. 25, 26, 27, 28, 29, 30, 31, 32. So 8 times 4 is 32. 8 plus 24 is 32. Professors, you will find that when most of the scholars do this simple problem solving and they're talking themselves through it, they will become better at prime factorization when they have to do the factor trees. So 8 plus 32. So let's see, 8 times 5. You can count by 5. Hello. We know that you can add 8 to 32, but in this sense, you can go ahead and count by what? 5s. 5, 10, 15, 20, 25, 30, 35, 40. So 8 times 5 is 40. And we knew that because 5 times 8 was what? 40. Now we will add 8 to 40 to get 8 times 6. Well, that's simple. 40 plus 8. See, it's just 8. So 8 times 6 is what? 48. Now let's pick up the pace. You should have it. Add 8 to 48 to get 8 times 7. You're starting to fly. 49, 50, 51, 52, 53, 54, 55, 56. 8 times 7 is 56. 8 plus 48 is 56. We need 8 times 7. Here's 8 times 7. So 8 times 7. Now remember, 8 times 2 was 16. So we need to add the 1 to 56. 8 times 7 is 56. 56 plus 1 is 57. Okay, so now we will move here. You can put a 0 here or an X. This lets you know, hey, I need to move to the tens place. We are regrouping with multiplication. Let me get a purple pen. Now, remember, 1 times any number is itself. 1 times 2 is 2. 1 times 7 is 7. Add it up. 6 plus 0 is 6. 7 plus 2 is 9, because it's 8, 9. 5 plus 7. Well, come down here to 7. If you need to do touch points to the side. Start with the larger number and then add on to the larger number. 8, 9, 10, 11, 12. So 5 plus 7 is 12. Again, start with the larger number. 8, 9, 10, 11, 12. Write your 1 in the thousands place. Write your 2 in the hundreds place. Write your comma there on the line. So, did we get it? 1,296? 1,296? Great, you did. So, let's take a look at that worksheet. 1,296. Let's look at the next. Number 3, 425 times 15. Turn your scratch paper over, and you will rewrite the problem. You have 425 times 15. Just good old-fashioned math, old school math, ones, tens, hundreds, thousands, 100,000s. All right? Now, let's take a look. We have 425 times 15. Look at what it equals. 6,375. How? Let's do the math. Let's physically get in there, synthesize it, and pull this apart by regrouping. 5 times 5 is 20. 5. If you need to touch it and see where that number came from, see, that brain is moving. Touch. 5, 10, 15, 20, 25. 5 times 2. Get up 5 fingers and let each one represent 2. 2, 4, 6, 8, 10. So 5 times 2 is 10. 10 plus 2, let me write it down for our visual learners. 5 times 2 equals 10. 5 times 3, add 5 onto 10. Or get 3 fingers up and count by 5s. 5, 10, 15. This is for my visual learners. This is just for you, not for my speedy bees, which is okay. I want my visual learners that are processing a little slowly to be speedy bees or to become speedy bees. 5 times 4. Well, add 5 to 15. Count by 5s to get 5 times 4. Or get up 4 fingers. You ready? 5, 10, 15, 20. 5 times 4 is 20. Or add 5 to 15. 16, 17, 18, 19, 20. 5 times 5. You can add 5 to 20, 21, 22, 23, 24, 25. Or you can count by fives. 5, 10, 15, 20, 25. Oh, professors, they're starting to fly. That's what you want. They're starting to understand and become less reluctant to problem solve. Again, so we know that 5 times 2 is 10. 10 plus 2, see? Visualize it. There it is. 0 plus 2 is 2. Bring your 1 down. That's how we know it's 12. We write our 2 in the tens place and carry our 1 to the hundreds place. 5 times 4. 5 times 4 is what? 20. 20 plus 1 is 21. We write our 2 in the thousands place. We write our 1 in the hundreds place. We put an X in the ones place. We cannot work in the ones place anymore. So if you need to choose a different colored pen or map pencil, do it. Visualize it. 1 times 5. Remember, 1 times any number is going to be itself. 1 times 5 is 5. 1 times 2 is 2. 1 times 4 is 4. Add it up. 2 plus 5. Remember, you can start with the larger number. 6, 7. Write your 7. 1 plus 2 is 3. So you have 2, 3. And these are called touch points. Some learners have to physically do the action in order for it to stick in the mind, like Velcro. 4 or 2 plus 4, start with the larger number. 5, 6. Did we miss something? Did we go wrong? Let's take a look. We missed something. We went wrong. Where did we go wrong? Oh, right. Don't forget, you can write an X here or a 0. We didn't add the number in the ones place. Are we right now? Let's verify. 6,375. 6,375. Great work. I'm proud of you. Let's pick up the pace and move to number 3. Now, we will not work all of these problems in this session. You will do the rest as an exit ticket on your what? Own. This is for practice. Learning your multiplication tables fluently will help you understand word problems when you begin to see the numbers surrounded by words. 425 times 15. Let's see if my green pen will work. Let's rewrite that problem. 425 times 15. Regroup. Ones, tens, hundreds, thousands, 100,000s. I'm ready. Are you ready? 5 times 5. 5 times 5 is what? 25. Write your 5 in the ones place. Carry your 2 to the tens place. 5, get my arrow right, times 2 is 10. 10 plus 2 is 12. I write my 2 and carry my 1. We just did this one. I thought this one was familiar. I thought it was familiar. I love it. Live recording. Real live teacher mistakes. Real live teacher mistakes. I should have done this. Should have kept up the same practice. 6,375. Now don't do that. Professor Matlock, write those numbers neatly. All of these numbers should be written neatly. All right, we were looking at number 4. That's where I meant to go. Number 4. All right, you ready? Good. Here we go. 303 times 83. Now remember, write those numbers neatly. A lot of mistakes are made when the numbers aren't written neatly. Ones, tens, hundreds, thousands, hundreds, 100,000s. Now I'm old school, so all of this here doesn't bother me. But please, if you need a clean scratch sheet of paper, get you a clean sheet of paper, or you're working out of a journal. I'm just old school. Here we are. 3 times 3. A doubles. A doubles. 3 times 1 equals what? 3. 3 times 2. Get up 3 fingers. Count by twos. 2, 4, 6. 3 times 2 is 6. Or add 3 to 3. 4, 5, 6. Now, I can probably hear an old school professor saying, or a new school professor, oh Lord, she's teaching them to count on their fingers. Yes, I am. Because it's response to intervention. And all learners don't learn the same. Some learners actually struggle with mental math. They are kinesthetic, they're hands-on, they actually have to touch it. I was one of those learners. That's how I became good at doing math and teaching those intervention strategies that helped me survive. That and my dad and mom. All right. So again, add 3 to 3. That's 6. 3 times 2 is 6. We're looking for 3 times 3. 3 times 3 equals, add 3 to 6. What comes after 6? 7, 8, 9. 3 times 3 is 9. 3 times 0. Well, 3 times 0 will equal 0. 0 times any number will equal 0. 0 times 1,000 is 0. 0 times 10,000 is 0. 0 times 100,000 or a million is going to be 0. Great work. 0 times, 3 times 3. Here it is again. Let's write our 0 here. 3 times 3 is what? 9. Write your X. Move to the tens place. 8 times 3. Well, let's get our 8 times tables going. Let's move here. 8 times 2 equals, get up 8 fingers, count by twos. 2, 4, 6, 8, 10, 12, 14, 16. 8 times 2 is 16. 8 times 3. Add 8 to 16. Let's go. 17, 18, 19, 20, 21, 22, 23, 24. 8 times 3 is 24. 8 times 3 is, write your 2. See, you're here in the ones place. 8 times 3 is 24. You cannot work in the ones place anymore. So you still must carry because you were here multiplying in the ones place. The 3 is in the ones place. So again, 8 times 3 is 24. So write your 4, carry your 2. 8 times 0 is 0. But you have a 2. So write your 2 here in the hundreds what place. 8 times 3 is what? One place. I might need to write this problem over. I don't want to confuse you. Okay. So now you've written your numbers. Let me write this problem over because that's my biggest sermon is when we don't write the numbers correctly, it throws the problem off. I want to write, let me make sure I've got some clean scratch paper. Okay. Here I go. I would be defeating my own purpose. And see, and I'm spacing those numbers out because I want you to actually process this lesson. Ones, tens, hundreds, thousands, 100,000. And someone says, do it on the calculator. You didn't do it on the calculator. 303 times 83 is 25,149. That's what it is. So that's where we're going. And I'm just going to transfer this to my clean document. So 3 times 3 is 9. 3 times 0 is 0. 3 times 3 is 9. Put an X here. I cannot work in the ones place anymore. We know that 8 times 3 is 24. We take a look. We're here. 8 times 0 is 0. But we have a 2 here. Eight times 3 is what again? Good, you remembered. 24. Let's add it up. 9 plus 0, this x is representing 0, is 9. 0 plus 4 is 4. And 9 plus 2 is what? Good. 11. Write your 1 in the hundreds place. Carry your 1 to the thousands place. 1 plus 4 is what? 5. And all you have is 2 left. Don't forget to write your comma after every third number. So 1, 2, 3, write your comma. Read your number, 25,149. Check your results against what you've calculated. 25,149. You've got it. You've got it. Not so bad after all. 25, 149. So that brings our lesson to a close today. Let me pull up that resource again where I got it from. I got it from Skill Builders Math, grade 6. Now remember, this is good for the intermediate level and above. Practice, 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 practice your multiplication tables daily, at least 30 minutes a day. Let me bring up my contact slide again. Here I am. I'm Miss Tessie Sanders Madlock, your response to intervention specialist for grades 1 through 8, and your adult ESL and adult education literacy online consultant for, of course, the upper grades, high school grades, and adult basic education level. Keep practicing. Keep studying. I want you to do very well and not struggle so much. I'm going to stop sharing my screen. In the upper level of math, especially when it comes to pre-algebra. Have a happy learning day.